Okay, welcome to Advent of Code 2023, Day 3, Part 1. So, with this particular problem, we have a grid, and I wasn't expecting a grid problem like this so early on. I think this year the difficulty level has been a bit all over the place in terms of the early days. It's ramped up pretty standardly throughout, but yeah, these early days seem to be a bit strange in terms of the difficulty level. I wasn't expecting grid problems so early on, like I said, but here we are. We have a grid problem on day 3. With this particular one, what we want to do is find any numbers that are adjacent to a symbol, even diagonally. They are the part numbers, and they should all be added up. So, for example, we have two numbers which are not part numbers because they are not adjacent to a symbol. So these are symbols. Dots are not included as symbols. So yeah, top right, 114. This one is not adjacent to a symbol, and it's worth noting with this particular problem, adjacency means up, down, left, right, and diagonals. So up, left, up, right, down, right. Normally it's just up, down, left, right, but we have all 8 directions to deal with. So we take all the numbers which are adjacent to a symbol, and we then add them all up. So in the test input here, which I've already popped over here, the sum is 4361, and as you can see, mine with my input was 519444. So that's the two numbers that we are going to be aiming for. So I decided to approach this with regex. So I've imported regex at the top here. I have seen other people explain their solutions where they started with the gears themselves, and then started with the symbols, and then found the numbers around, and then found the beginning and the end of the number. But what I did instead was go over the row, find the numbers given the start and the end points. For each one of those, check around it to see if there were any symbols, and if there were, great, that's a valid number. Otherwise we just move on. So here goes, using regex. So the first thing we want to do is we want to make a grid. So let's just say the grid is equal to the string, which is the input text, and we want to split on the lines. We then have because we need to check all of these different directions, it's worth, I think, making a directions variable at the top here. So this will contain all the different directions that we're gonna go in. So firstly, we're gonna check. So yeah, basically we need to go -1 to 1 in tuples of 2. So -1 1 1 -1 0, so on and so forth. So we have -1 -1, so that's up 1 row, left 1 column. We then want -1 0, so that will be up 1 row directly. Shift over no columns. Then we want to go up 1 row, but go to the right 1 column. We want to then check not going up or down, but going to the left only. We want to check for going right only. And we then have the down, the increase of row. So this will be 1 -1, 1 0, and 1, 1. Cool. So we have our total variable at the top there again, so we're returning a number. So so we want to get the index of the row and the row itself. So if we do for R and row in enumerate the grid, like I said, I'm going to use regex for this. So what we want to do is pull out all of the numbers within the string, all of the sets of numbers. So all of the matches, we want to get all the digits where there is at least one, but we want to the end of that group of digits, and find iter on the row. We're going to use find iter because if we just did find all, it would just return the numbers, whereas find iter actually give us a match object which has the start and the end positions, which is actually what we care about. We can then use them throughout the rest of the code. So for m in matches, what we want to do is we want to have a way of breaking out of keep going over the same stuff. So I'm going to have a match used variable, set it to false. And then what we want to do is we want to go over the columns that are within the range of the number. So for example, 4, 6, 7 over here, we want to go 0, 0. Let's forget the row for a second. So we want 0, 1, and 2. And for each of those, what we're going to then do is go around all of the directions. So for 4, we're going to try up, down, left, right, and the diagonals. Obviously, we can't go up, we can't go left. We can only go down and right. Same for 6, 7. We can't go up, but we can go down, we can go left, we can go right, so on and so forth. So we're going to try each of the directions for each of the columns within the range, and we're going to check for a symbol. So because we can't just jump out of a specific loop, and because we're nesting lots of different for loops, that's why I'm creating this match used variable up here, and then we can set it to true later on and then just break out of it if needs be during the processing. Cool. Okay, so match used is false. So then what we want to do is for MC in range, so this is the match column, in range m.start to m.end. If match used, we are going to break. Cool. So then we want to go through each of the directions. So for D in directions, so this is where we're going to check all of the different up, down, left, right, and diagonals as listed above. So what we want to do here is we want to say if R plus D0 is less than 0, or let's just wrap these in parentheses just in case we've got some issues with things playing silly buggers. So we have then R plus D 0 again, but this time is greater than or equal to the length of the grid. So if it's greater than or equal to the length of the grid, we're gonna exit. So these are all the conditions for if we're gonna exit. So then we want the column plus D1 is less than 0. So if it's going to the left too far, or then we want MC plus D1 is greater than or equal to the length of the row, then we are going to continue. Cool. If we don't continue, we then want to set the character to be grid. We want the row plus the D0, and the column is MC plus D1. So if character does not equal dot and not character dot is digit then so if it's not a digit, because we don't care about those, and if it is not a dot, so it does land on a symbol, then we're going to go total plus equals int of m dot group 0 match used as true, and we are going to break out of this. Cool. Right, so what issues we got here? So we just need that on there. Right, let's see if this worked. Okay, so we get nothing for both. Okay, let's see what is going on here. So total plus equals m dot group 0 equal to that, or that 0 and that is greater than or equal to that. Let's just wrap these a little bit nicer. Just so we can actually see all these conditions properly. Oh, that actually looks disgusting. Oh, I can't believe I did that. Okay, so we get nothing. So let's just print so we want to print the row. Let's print the D, and let's print the MC. Nothing, never gets there. Great. So if R plus D0 is less than 0, is greater than or equal to the length of the grid, or if that is less than 0, okay. Match columns, D direction. It never gets to there. Okay, let's okay, if R plus D0 is less than 0, continue. If R plus D0 is greater than or equal to the length of the grid, I'm going to continue. I'm going to add some print statements in here as well. So if MC plus D1 is less than 0, continue. In fact, let's simply print all of this. Let's just pop it up here. Never gets there. String split lines directions for row in enumerate grid matches is all of the digits Let's just see if that ever gets a match. No. Well, of course not. Okay, so what did I do here? Oh, this needs to be a raw string. There we go. Right. Let's just take out these debug stuff things. Oh, that's horrible. I'm going to leave it. Okay, so we get 4361 and 519444, which we can see here, 4361 and 519444. So the way that we did this was we went over each of the rows in the grid. We then got all of the individual numbers using regex and find iter, which gives us the start and end point of each of the numbers. For each of the matches, we then use the start and the end point to draw around, or to check around each point to see if there was a symbol. If there is, we then add that the whole number that was matched. We add that to the total. And that's it. Nice and easy. It's a simple problem, but the trying to navigate the regex can be fun, and also just getting the order in which to check around things. So like I said earlier, I've seen other people explain theirs where they find the symbols first and then find the numbers around them, which is a great approach. I just went for finding the numbers first. Regex is always fun to use. But yeah, so that was day 3, part 1. So then we have part 2 as well. So part 2, we have slight variation on the problem again. So this time there is missing parts and so on and so forth. One of the gears in the engine is wrong. So a gear is any symbol that is adjacent to exactly 2 part numbers. Its ratio is the result of multiplying those 2 numbers together. So this time, given the same grid, you need to find the gear ratio of every gear and then add them all up so the engineer can figure out which gear needs to be replaced. Consider the same engine schematic again. So there are 2 gears in this one. The first is in the top left. It has part numbers 4, 6, 7, and 35. So it's that one. So this one here. So then we multiply those together to get 1, 6, 3, 4, 5. The second gear is in the bottom right, which I believe is this one here. So we get 755 and 598. And that gives this number. I think it's this one. And then it says here the star adjacent to 617 is not a gear. This one here, because it is only adjacent to 1 part number. Adding up all of the gear ratios produces 4, 6, 7, 8, 3, 5, and then we have to do the same for ours. So yeah, same input, which is this lovely huge grid. Okay, so this one, I took again an iterative approach, but this time I actually I definitely didn't go for the optimal speed solution with this one. I actually went over things twice, but yeah, well, let's see how I did it. So again, we have the grid, which is equal to the string dot split lines. What we want to do, we want a list of all the gears, firstly, and let's go with some numbers. So firstly, what I'm going to do is add in to all, so basically populate the gears and the numbers, and then after we populated all the gears and the numbers, is go over the gears and check how many numbers are within the range. Probably could do it in one go, but yeah, I decided to do it in 2 separate ones. So for our row in enumerate grid, gear matches is equal to re dot compile. So it's specifically all of the stars this time, which is quite useful. It's not any symbol, specifically the stars. So we're going to use an actual raw string this time, not a formatted string. And again, we're going to do .find iter, and we're going to give it the row. Find iter re.compile. What's wrong with that? Oh, we don't have regex imported. Let's pop that back up there. Let's go to the top. Import re 21j. Right, so then we're back to here. So for G in gear matches, we are then going to do simply gears dot append, and we are going to append a tuple of the row and the G dot start. Cool. So then we have the num matches. So we check the row for all of the numbers. So num matches is a list. We want it to be a list of re.compile. We don't necessarily need it to be a list, I don't think. Matches re.compile. And this one is going to be the digits again, one or more, dot find iter in the row. Okay, so then what we want is for n in num of num hatches, nums dot append, and we are going to append the integer of that. That of the actual match. We're then going to do the row, and we're going to do the n dot start and n dot end minus 1. Cool. So this gives us the so end, I believe, is the column after it's ended. So we want the actual column that it's actually contained within, not the one after it's ended, which is why we're doing the -1 here. Okay, so there is that. So that's the first time over the grid. So then what we want to do is for G in gears, or for each gear, we then want to do G nums is equal to a list. I suppose we could do actually gnums is 0, and we actually just count how many there are rather than always appending to a list, which is what I originally did. I made a list of the matching ones, added them all, and then said, okay, are there 2? If there are 2, then we're good. Carry on. Otherwise, if there is not 2, which is the problem, then we don't do anything. So instead, this time I'll just do a count. So gnums is this. So for n in nums, for the column in range. We want to go for the second -1, and in 3 + 2. The reason we're doing -1 to +2, so if we see here, so we have 0, 1, 2. The start, we want to start from the column beforehand, and we want to go from there to the end, which we've said is -1, so we want to then add 2 on the end to capture everything we need. Cool. In the range of that. So what we're going to just do, G, we're going to then just check to see if G1 is equal to the column and G0 is in range of n1 - 1 n1 + 2. For each of the numbers, and then we're going to go over the range, and G is in the range of that. Yep. So then we're just going to do G nums plus equals 1. If G nums is equal to 2, we're going to then do total plus equals oh yeah, so we do actually want to keep track because we need to multiply them together, the two different numbers. So we do need this, and instead of doing the count, I'm going to do gnums.append, and we're just going to append the number, which is what we've put in there. Cool. So then the total is equal to the group nums 0 multiplied by G nums 1. Let's just see if that works. I don't have much faith. Nope. Of course it doesn't. Okay, so what are we doing here? What did we do wrong? Solve all of this. So we have all of these for each of those. All of the numbers, all of the gears. Okay, let's just do print gears is equal to that, and nums is equal to that. Okay. So nums is definitely getting something. That was the gears. Yeah, gears is getting stuff as well. Okay. So for each of the gears, for each of the numbers, G1 is equal to that G0 is in range n1 minus 1, n1 plus 2, append that. It's never going to equal 2, but the length might. There we go. So we have 467,835, which is there. And we have 74528807, 74528807 for my input. So there we go. There is the solution to day 3 of AOC 2023. I found this one relatively tricky to do. Yeah. It was fun, but tricky. So yeah, stay tuned for day 4. See you later.